Two-step equations, topic 15-1, Envision Math 6. You've solved one-step equations. Now we're going to be learning how to solve two-step equations. Solving equations involves the use of two important ideas. First, we want to talk about inverse operations. And inverse operations are operations that undo another operation. Addition and subtraction undo each other, so they are each other's inverse operations. An example of this would be if I have 8 and I add 3, that would give me 11. Well, the inverse, or to undo that addition, I would start with the 11, and then instead of adding 3, I would actually subtract 3, which is the inverse or opposite of adding 3, and that would take me back to 8. So that subtraction undid the addition. Multiplication and division also undo each other. An example would be if I do 4 times 6, that would give me 24. I could undo this operation by starting with that 24. Instead of multiplying by 6, I would divide by 6 because dividing is the opposite or inverse of division, and that would take me back to 4. So the first important idea is these inverse operations. The second important idea involves properties of equality. These properties state that you can add, subtract, multiply, or divide by the same number on both sides of an equation, and the two sides will remain equal. I have referred to this as the golden rule. The golden rule says what you do unto one side, you must do unto the other. Are these examples following the golden rule? Let's look at the first example. We have 4 times 5. And we are adding 2, and then that equals 20 plus 2. Well, 4 times 5 is 20, so we know those are equal, and we're adding 2 on the left, we're adding 2 on the right. So that is following the golden rule because we are using the addition property of equality to keep the equation balanced. What about the second equation? We have 24 minus 10 equals 6 times 4 plus 10. Well, 24 equals 6 times 4. And on the left side of the equation, it is subtracting 10, but on the right side of the equation, it is adding 10. So this one is no. It is not following the properties of equality. It is not keeping the equation equal because the same thing is not being added or subtracted to both sides of the equation. Now we're going to solve two-step equations. Here's what to do if an equation has more than one step. First off, you always want to combine like terms if you have any. In this example, x plus 4 minus 3 plus 2x, I would need to combine the x's, the 1x here and the 2x, because they are the same, and then I would also need to combine the regular numbers. So x plus 2x is going to give me a total of 3x's, and then 4 minus 3 is going to give me 1. So it would combine to equal 3x plus 1. Our second step would be to use inverse operations to get the variable alone on one side of the equation. It is easier when we're doing inverse operations, if we undo addition and subtraction first, then undo multiplication and division. And last, we are going to be checking our answers using substitution. In this sample equation, 4x plus 5 equals 17. I look at step 1. Do I have any like terms that I need to combine? No, I have only x's plus 5 on the left, 17 on the right, There isn't anything that I need to simplify on either side of the equation. So now I'm going to start doing those inverse operations. I want to undo addition and subtraction first. So over here on the side of the equation where my x is, on this side, I have a plus 5. So I'm going to get rid of that by subtracting 5 from both sides of the equation. 5 minus 5 gives me 0, and 17 minus 5 gives me 12. I bring down my 4x and the plus there. So now I have 4x plus 0 equals 12. Well, since it's adding nothing, I can really just ignore that part. Now I have 4x equals 12. Since 4 is being multiplied by x, I am going to undo multiplication by doing the inverse operation, which is division. So I'm going to divide by 4 on the left side, which means, using the golden rule, I also need to divide by 4 on the right side. 4 divided by 4 equals 1, and 1 times x is just x. 12 divided by 4 is 3, and then I still bring down that equal sign. So I have just found that x equals 3. In order to check this, I start with my original equation, and I substitute my answer back in. So I would substitute 3 for the x. So I would say 4 times 3 plus 5 equals 17. That was my original equation. Now I simplify. 4 times 3 is 12. I do it just one step at a time. So it'd be 12 plus 5 equals 17, and then I will add 12 plus 5, which will make 17. That equals 17, and if those two are equal, then I have successfully checked my answer. So let's look at some sample problems here. The first one, 22d minus 15 minus 2d equals 65. Well, I can see here on the left side of the equation I have 22d's, and then I have 2d's that want to be subtracted. So if I combine those terms, that's going to give me 22d's minus 2d's is 20d's minus 15 equals 65. Now I want to undo addition or subtraction. On the left side of the equation, where I have the d, I see there is a minus 15 happening. So to undo that, I am going to add 15 to the left, which means, following the golden rule, I also add 15 to the right. That gives me 20d minus 15 plus 15 is 0, so those basically cancel out. I don't need to write them. And 65 plus 15 will give me 80. Now I'm going to undo any multiplication or division that I see. Well, 20 is being multiplied by d, so I'm going to use the inverse operation. The opposite of multiplication is division, so I'm going to undo this by dividing by 20 on the left. I undo that by dividing by 20 on the right. Well, 20 divided by 20 equals 1, and 1 times d is simply d. And then 80 divided 20 by 20 is 4. There are 4 20s in 80. So my answer is d equals 4. I check this with substitution. So I have over here 22 times 4 minus 15 minus 2 times 4 equals 65. If I simplify, 22 times 4 is 88. And since I'm doing multiplication, I can also multiply these two terms. 2 times 4 is 8. Now I still have the minus 15 and minus in front of that 2 times 4 equaling 65. Now I can say 88 minus 15 gives me 73 minus 8 is 65. And then when I subtract 73 minus 8, that does equal 65. So I can say 65 does equal 65. I have successfully checked my answer. Here is a problem for you to try. If you are not sure how to do it, then go ahead and let the video play. Otherwise, hit pause, and when you hit play again, the answer will appear. So I have r divided by 3 minus 14.6 equals 7.3. It does not look like there's anything to combine, so I will skip that step. So I'm going to undo addition and subtraction first. Since we are subtracting 14.6 on the left side of the equation where the r is, that means I want to add 14.6 to both sides of the equation. Well, 14.6, or minusing 14.6 and adding 14.6 is going to give us 0. So that is still r divided by 3. I don't need to write the plus 0. And then 7.3 plus 14.7 will give me 21.9. Now, to get rid of the divided by 3, I need to do the opposite. Well, the opposite of dividing by 3 is going to be multiplying by 3. Well, if I look at the fraction over here on the left side, that is 3 over 1 times r over 3. I can cross cancel those 3's, which will just give me 1 and 1. And 1 over 1 times r over 1 is just going to give me 1r over 1. That's just r. Now 21.9 times 3 is 65.7. So that is my answer. I will check it by substituting 65.7. I put that in place of the r. Divided by 3. Minus 14.6 equals 7.3. So first, 65.7 divided by 3 is 21.9. Minus 14.6 should equal 7.3. Now I do 21.9 minus 14.6, which gives me 7.3 equals 7.3, and I have successfully checked my answer. Here are 2 more problems for you to try. Hit pause, and when you hit play again, the answers will appear. X divided by 4 minus 5 equals 19. There's nothing to combine, so I will undo the minus 5 by adding 5 to both sides of the equation, which will give me x divided by 4 minus 5 plus 5 is 0, and 19 plus 5 is going to give me 24. To get rid of the division, I will multiply by 4 on the left, multiply by 4 on the right. If I change that into a fraction, I can cross cancel, which will just leave me with x equals 96. To substitute, I do 96 over 4 minus 5 is 19. 96 divided by 4 was 24, minus 5 equals 19, and 24 minus 5 is 19 equals 19. I have successfully checked. On the bottom problem, I would first combine 5x minus x would leave me with 4x plus 4.2 to equal 13.8. I want to get rid of the adding 4.2 by subtracting 4.2 on both sides, which will leave me with 4x equals 9.6. I still have the 4 on the left, multiplying by the x, so to get rid of that, I need to divide by 4 on both sides of the equation, and that gives me x equals 2.4. Now I'll substitute 2.4 in for x and check my answer. So I've substituted 2.4 for every x, and 5 times 2.4 right here will equal 12, plus 4.2 minus 2.4 should equal 13.8. 12 plus 4.2 is going to give me 16.2. I'll need to still minus 2.4 to hopefully equal 13.8. And when I do that subtraction, I get 13.8 on the left. That equals 13.8 on the right. I have successfully checked my answer. Go ahead and do your quick check and see how well you understood today's lesson.